So, shifting gears, we're going to go back to talking about this towers, how I got this deployed to the internet and how you could get your apps deployed to the internet. So we talked about making an executable jar last time. I did one manually, and I also briefly showed you how to do it with a pom.xml, which is it's gross syntax since it's all based on XML. But this is how you can do it. You can do it the same way I did it. I Googled Maven Executable Jar with dependencies, and you'll get something that looks just like this. You can cut and paste it and then swap out your main class. Is the only configuration that I did. Swapping out that main class. Everything else has to be here. I've played around with this trying to understand what the hell it means, and I'll delete something that seems useless and then it just breaks. But if you set it up like this, it'll create that executable jar with all the dependencies installed. So we have the Docker file, which is going to run Maven. That downloads the dependencies, builds the jar, does all the things. And then I'm going to run that jar using Java. Again, this is Java bytecode. There is no Scala code that runs ever. It's compiled into Java bytecode and then ran as Java code. Seems so loud. Then runs as Java code. So we compile the Scala to Java bytecode and then run it in Java. We're going to specify that it's a jar and then specify the file. It's going to be in my target directory, and it's going to be named this long thing. So that runs the app. Again, just to take it from the top on this one, I started with Ubuntu, installed all the things I need, Scala, the JDK and everything, got all my project files in there, ran Maven to build the executable jar, and then run the executable jar. This will run on port 8080. It's listening for WebSocket connections on port 8080. So whenever we get a WebSocket connection on port 8080, this is going to handle what we need to do there. We also have another Docker container, which is running just Nginx with my front end and configuration files listening on port 80. There's a lot of stuff going on with ports with this. Part of that is just the way I have it configured. I have a lot of ports bouncing around and stuff, but there's a lot going on with ports here. So Nginx is listening on port 80, and if it gets a request on port 80, it's going to check to see if I have a file with the name of the request. So it's going to look in my public directory and look for a file. If somebody requests /index.html, they're going to get my index.html, or if they request just /, I want to serve up my index.html on the root path of just /. If the request is for /socket.io, I'm going to forward that to my app on port 8080. So I'm going to say, hey, this request is for the app. Go into the app, say, hey, app, on port 8080, this request is for you. And it's going to act as a reverse proxy. So the clients are talking to Nginx directly, and then Nginx is going to be a reverse proxy which talks to my WebSocket server running the Java bytecode. And then I'm forwarding some headers, some configuration to make sure everything works. Specifically these two. If you don't have these two here, WebSockets don't work. You have to forward these headers to the app to be able to get WebSockets working. So we have these two things running, but these are running as two completely separate processes and actually in two completely separate Docker containers, which a container is effectively a virtual machine. It's like a lightweight virtual machine. So it's like having two, kind of like having two completely different computers running these two different apps. So we need to have them communicating between each other, having these two containers being able to be ran without being a pain, and being able to communicate with each other. For that, we're going to use something called Docker Compose. So Docker Compose is going to take multiple containers and do exactly what we want. It's going to run them both, build them both, and allow them to communicate with each other. So in my Docker Compose, I'm going to say, I want two separate containers, one for Nginx, which is going to use my Nginx Docker file. So I'm giving it the path to where it can find a Docker file for this container. And also my app itself, which is going to find a Docker file in this current directory. The Docker file is right there. For Nginx, I'm going to do some more port magic. I'm going to map my local port 9009 to the container's port 80. So Nginx inside the container is running on port 80. Each container and my machine itself, it has a complete different set of ports. So inside the container, Nginx is running on port 80. I don't want to use port 80 on my laptop because I'm probably using that for something else. I'm pretty sure I have Nginx running somewhere. It's probably not even doing anything, but I don't want to clutter up port 80 because I can only do one thing at a time if I do that. So I'm going to pick a randomish port number for my host machine, so I'm not having all of my apps that I'm developing conflicting with each other and fighting with each other over port 80. Port 80 is the default port for HTTP. So when you want to do web stuff, any HTTP stuff is going to happen on port 80 by default. But I'm going to override that and start using port 9009, for example. If you're not running on port 80, you have to specify the port. So when we go live, when we get to that side of things, we don't want somebody to have to type jessehartloff.com:9009. We don't want that. So in the end, we're going to get rid of that. But inside the container, we're going to run port 80 and then use port 9009 for this app on my server. So now we have both of these running, and these names are going to be the host names for each app, for each container. So inside Nginx configuration, I did app:8080. So I'm saying the container named app, that it's port 8080, that's what I want to connect to. So if I run docker compose, there's a command docker compose up. If I want to run the whole thing up is the command. And then it'll take, oh my goodness. I don't have Docker running. That's a problem. I mean, we don't need this part of the demo, but we're here, we might as well. But once Docker's running, I can just say docker compose up, and that does everything. This is what we like for deployment, is one simple, straightforward command that just builds the whole thing. So once Docker's running, I can do docker compose up, and it looks like I already built this, so it went really quick. It usually takes a long time, does a lot of work. But docker compose up, Docker's really smart about not doing extra work. So if it's already built, it's just going to use the already built stuff. So it builds both containers, it compiles my code, gets the executable jar, runs the executable jar, starts Nginx, builds the network map, and then exposes port 9009 locally. So if I go to my browser and everything worked right, I should say localhost 9009, and I should be seeing towers. Which I am, yay. So the app's running locally with one command. That's how simple things should be in the end. So when I go to my deployment server, the server that's going to be running 24/7 and actually hosting the app, I just want to go to that server, docker compose up, done. I want that to be how easy it is. I want it to be that easy to deploy something. And Docker is a fairly new technology to software engineering. Deployment used to be way more painful before Docker came around. But within the last 5 years or so, I think it's been about 5 years since it really became popular, Docker came around and just revolutionized I shouldn't say revolutionized, it's not quite that strong, but really took over software engineering and is a pretty standard way that we deploy now. And then there are more tools like Kubernetes. I can't even think of a second example. It's really Docker. Docker is the way to do things. And then using other technologies in conjunction with Docker. So it makes it simple to run our apps. And it gets rid of the problems of, well, it worked on my machine, but it doesn't work when we go to deploy, because the containers are identical, at least as close as they can. I'm starting with a fresh Ubuntu 18.04 and then running these commands and stuff. It doesn't matter if you're running Windows, Mac, Linux, the container is going to be running Ubuntu. End of story. So no matter where I go to deploy this, it should, at least in theory, and most of the time it does work this way, it just works. If it works on my laptop, it's going to work anywhere else. So anywhere else, then we'll ship your machine. So anywhere else, we do that same thing. So anywhere else, in my case, is going to be a DigitalOcean droplet. I like DigitalOcean. I don't want to give them like free advertising. I'm not sponsored or anything like that. But I do like DigitalOcean for my personal preference. There are a lot of different servers you can get out there. But what DigitalOcean is going to get me is I give them $5 a month, well, $10 a month because I have 2 of them. And they give me a complete container. I believe they're using containerization. They call them droplets just to abstract what they actually are. But when I log into it, it's just a machine that's running Ubuntu 18.04, and they give me root access. So I can do anything I want with this machine, which is almost certainly a virtual machine. And I get a static IP address. And that's all I need. For my purposes, that's all I want. I'm comfortable in the command line. I would just want to SSH into this thing, go into the command line, and play around. So if I go to my terminal and SSH into this machine, I have Ubuntu. It's just an Ubuntu machine with a static IP. I have root access. I can install whatever I want. I can download whatever I want. I can do whatever I want here. I can mess with any configurations, and that's exactly what I want for my purposes. I don't want anything more than that. DigitalOcean provides it. It does have extra features that I don't use, but this is all I want. Give me a machine and give me root access. If that's not your style, there's AWS, Heroku, many others where you can deploy your apps and have less control, I'd say. And more features, more like usability features. So if you're into that, go that way. For my purposes, I like DigitalOcean because it lets me do things. I know what I'm doing, and I just want to be able to do it. So when we get to this server, so I already have towers running here. I just do Docker PS, and that's going to show me all the processes that are running, all the Docker containers that are running. So I have towers running right here, and we can see right here the Nginx portion of towers, that container, is mapping localhost 9009 to port 80. So I didn't change any of the ports. The way you saw my configuration in IntelliJ, that's the way I have it configured on the server as well. It's running on port 9009. But when you go to jessehartloff.com, we're not doing port 9000. Oh, come on. We don't have to specify port 9009. I believe we can if I grab my IP address. I don't know if this is blocked or not the way I have it configured. No, it isn't. So we can go directly to that port 9009 by my IP address. But that's gross. Like if I sent you this link and said, come check out my game, you shouldn't click on that. That's super sus. I wouldn't click on that thing. So we want just jessehartloff.com. So to get that, I might be able to get through all this today, which I don't know what I'm going to do Friday, so I kind of don't want to, but I'm just going to go through it and get through everything today. Use just promo code Jesse for 0% off today, exactly. So I get my domains through Google Domains. There's tons of different services where you can get your domains. I like Google Domains interface. It's nice and easy to use. So I have jessehartloff.com that I purchased. And I want to go to the DNS settings for this domain name. So I bought a domain name from Google. I have my DigitalOcean droplet, and I need to connect the two. Of course, this is already configured. So what I do is go to the DNS and add a DNS record that says, whenever you get a request for this domain name, send that request to this IP address. Just like DNS is supposed to do, I have an IP address. Everything over the internet works off of IP addresses. You request something by IP address. There's no other choice, no other option. DNS is something just for us humans where we can say, associate this domain name to this IP address. So that's exactly what I'm doing here. I bought a domain name, and I'm saying this domain name, associate that with this IP address. So when you type in jessehartloff.com, you're making a DNS request for the IP address, and then the IP address is 158.89.179.140. That's what you're actually sending a request to. That's the machine that you're sending a request to. So now I have jessehartloff.com linked to my IP address, but there's one more problem. So jessehartloff.com, you're going to make a request on port 80, and more specifically, port 443, because we want to be secure. When you go to jessehartloff.com, you get this nice lock, and we're actually connected with HTTPS. We're all encrypted, we're secure. That's what we want. We want all that nice security features. So to get that, we have another layer that we add onto this. And if you notice, I have multiple apps running on this server, and all of them are running on kind of random port numbers. None of them are running on port 80 or 443. So what I have is actually another layer. On this droplet, I have another instance of Nginx running. So I actually have to use towers. I'm using 2 instances of Nginx. It's kind of silly. I kind of want to refactor that. But at the same time, I think it's silly in a good way that I have 2 Nginxes running. And there's nothing wrong with it, but it just seems weird. But if I go into my Nginx configuration, there's not much to see there. Site's enabled. I have a configuration file for each app that I'm running on this server. So for example, if I go into jessehartloff.com, I have configuration that says whenever you get a request with the domain name jessehartloff.com, send that to port 9009. So here, this part of it, I'm listening on port 80, and I'm saying if you get a request on port 80, redirect it to the secure version. Don't let anybody access this in an insecure way, which I just showed that you can do by directly going to the IP and port, which I should disable. I should set configuration up so you can't do that. But if you request over HTTP on port 80, don't allow it, send them to the secure version. The secure version is going to have all the encryption configuration, which certbot, fantastic tool. It configures and sets up all my encryption for me. Very handy tool, very useful. Some that really pushed encryption, made it quite easy to implement. And then if we get a request here on port 443, a secure request, then forward it to localhost port 9009, which forwards it to that Nginx's port 80, which then, if it's a WebSocket request, forwards it to the app container's port 8080. So we go from port, if somebody requests the insecure version, we're going from port 80, a redirect to port 443, a forward to port 9009, which goes into a container, port 80, which goes to another container, port 8080, and then back throughout the chain. So there's a lot of port stuff going on. I never really thought about it until I was thinking about this lecture. I'm like, yeah, I got a lot of port stuff going on, for what it's worth. It doesn't have to be that complex, but just the way I configured everything, it ended up being that complex in terms of ports. So that's the whole chain that everything goes through to be able to get my request there. And then for any other app, it's the same exact configuration. I just forward to a different container by specifying a different port. So if I get a request on the server for CSE116.com, I forward that to a different container by specifying a different port. So then I can have one server, one droplet in this case, hosting many, many apps, however many apps the hardware can handle, which as it turns out is a lot if you don't have a lot of traffic. If you don't have like tens of thousands of concurrent users, web servers can handle quite a bit. By having Nginx sit there as a reverse proxy and then route traffic to the appropriate port, i.e. the appropriate container for each app. Which I think is everything I want to talk about like that. So I know that goes by super fast, partly because it's not something that you're required to do. But any questions on that for those of you who followed any of it? Any questions? Are you confident you could get a domain name and deploy your apps? I got through everything I want to do. I don't know what I'll do Friday now, but yeah, see you Friday. Yo.
What do you have to say about rumors that you are inspired man no way home?
That I'm a what?
You're inspired man no way home. Why are the rumors? You're in part of the home first.
I've been inspired on the way home. Did you hear? Yeah, well, I want to react. I want to give my opinion, but the rumors that I'm a what?
That you're in the movie.
That I'm in the movie?
Are you in the movie? Yeah. Spider.
It's in Spider-Man? In the new one?
Yeah.
Well, I can't comment on that. My agent would kill me. Specifically a million. All right, yeah, see everyone Friday.